Hello everyone. Okay, in this video I'm going to show you how to scan an object with the 3D probe. For those of you who haven't seen the other videos, I recommend you to look at them. In the other videos I explain what is the 3D probe, how to use it, how to connect it to the Stepcraft. Okay, the 3D probe is basically a super sensitive switch that when you touch it in any direction, it sends a signal to the machine and to the UCCNC. So it acts very similar like the zero tool sensor. Okay, what we're gonna do is to scan this object with the probe in this manner, in this way. This is going to be here, and the probe is going to go down and touch all the surface of the skull. And we have a 3D reproduction of the coordinates that the sensor sent to the machine. First, what you have to do before you scan an object is to see the approach on how to scan it. For example, in this case, most of the surface in this area, I can scan it normally, and I can go down the probe all the way. Most of the times you are limited to the length of the tip of the 3D probe, because here it's a collet that holds the tip. So if you go in a narrow area, the collet is going to touch one of the corners. So in this case, most of the surface I can go everywhere without a problem. The only problem that I have is this area here. So if I try, for example, if I try to scan outside this area, the probe is going to touch here on the collet. Because of the length, the difference here is the highest point of the object, and here is the lower point of the object. If I want to touch here, for example, I have to go down all the way here. So if I try to go all the way here in this area, it's gonna touch. Let me explain you about the logic, how this is gonna work, so you can understand the procedure. We're gonna use the same plugin that we used before for the 3D mapping of the Toolpath. What that plugin does, it maps a grid with points. So if your surface it's not regular, it's in some way irregular, it automatically maps the toolpath to the surface. With that, the same approach, we're going to use the same plugin to map this surface. The way the plugin works, it's you set up the mesh you want to scan. You want to probe for putting your toolpath in that area. So there's a little trick that we're going to use. The plugin uses a macro. It's called 331 macro. Every time the probe touches the surface, the macro gets activated. So what I do is I write a little command on the macro, and with that command, every time the probe touches the object, saves the coordinate in a special format, so we can have that point inside a file. And that file we're gonna load it later on the on Meshlab, so we can reproduce this as an object. Now, how are we gonna do this? Well, it's not difficult. What we're gonna do to scan this area, first we're gonna measure the skull, and we're gonna set up this on a square boundary on a box. So we're gonna make a toolpath, just a simple box that is the size of the skull. So when we put that toolpath on the plugin, we're gonna tell the plugin that we're gonna make a square in certain area. The area is gonna be the size of the skull. So we're gonna tell the plugin that we need. That depends on how we want to make the scan, how accurate we want it. I make some tests, and to obtain a very accurate representation of a surface, we can have 1.5 millimeters distance between each point. So it's going to be a grid made of little points 1.5 millimeters from each other. So we're going to have a very nice representation of what we're going to try. In this case, after we measure this and set the toolpath as a square, tell the plugin that we're going to put that square in this surface, the plugin is gonna try to scan all that area, so we can put the toolpath square, the square toolpath, we're gonna put it in that area, but that's where we stop. We're not gonna mill or anything, just we want the plugin do the scan. I talked with Cahit. He's the one that made this plugin, and I let him know what I do with the plugin, with the trick that can save the coordinates. And he told me that maybe in a future release he's gonna make these changes. So maybe in later versions of the plugin we are not gonna need the trick to scan the object. Maybe on the plugin we have the option, so we can put scan, set the size of the scan, and we can scan any object that we want. Well, that's what we're gonna try. We're gonna put this here on the table. We're gonna set this. We're gonna measure the skull, and also one other cool things. As I said you before, the approach that I cannot go all the way down here because the probe is gonna touch here on the collet. I'm gonna put the skull in this way, and with the same tool, with the macros I write, I'm gonna find exactly the edge of this side and the edge of this side. So because I don't want to be exactly on the edge, I'm gonna move my toolpath, my zero from this. I'm gonna make a corner for the toolpath here. So with this, I'm gonna touch here. I'm gonna know this coordinate. Then I'm gonna touch here. I'm gonna know this coordinate. So I know this corner where the object starts here. Then I'm gonna touch the top, and I know exactly the corner that is gonna be on the box of this skull. And what I'm gonna do to not go exactly here, I'm gonna move my toolpath, my zero on the UCCNC 1 millimeter inside the skull. So when the probe touches, it's not going to touch exactly the edge, it's going to touch 1 millimeter inside. So it's going to touch exactly here, and I'm not going to have the problem that the probe touches outside. It's only for this object. This object have this problem because I want to scan these these holes here. Okay, well, let's do it, and I'm going to explain what is the settings and where the object is going to save and etc. on the computer. Okay, the first thing we're gonna do is, after we put the object on the table and measure the object, we're gonna make the toolpath to make the boundary of the object. So we create a new file, and it have the measures. It's 70 millimeters by 100, and the thickness, it doesn't matter, it's say 1 millimeter, and this is going to be the area of the toolpath. Also, to make the toolpath, we need to make a square that is going to be 70 by 100, and that's going to be our toolpath, and we are going to center this on the area. And then this toolpath, we're gonna make a simple profile. No, it doesn't matter which end mill you use. Everything's gonna be like whatever you want, because we only use this as a boundary box for the scan process only. So calculate this, and we're gonna save this toolpath. Actually have several toolpaths here, and let's say object probe school. Okay, now what we need to do is open the UCCNC and load this toolpath on the plugin. Okay, I just load the UCCNC and I have the plugin here. For those who doesn't know how to activate that plugin, it's here on the configuration, general settings, configure plugins, and you have to turn this to on, call it startup and enabled. And if it's the first time, you have to reload the UCCNC to activate the plugin. Okay, now before anything, we need to home the machine. Okay, after we home the machine, let's zero everything, and we're going to move the gantry to the top of the object, and we're going to start making first the square. We're going to find the square corner for the toolpath. One thing I forgot to tell you, it's on the when you make the toolpath, make sure that your object is on this corner. You can do it in any other corner, but because of my kind of object, I prefer to do it here because I have more visibility on this area, on this side from where my computer is. So I decided to make it on this corner. So all my job is going to be here. Now, here let's move the gantry to the top of the object. Okay, I have it right in front of my object, and what I'm gonna do is I'm gonna measure first this corner. This is the macros that are going to come with the 3D probe. So I need to find this corner and this corner. Once I have these two corners, automatically the macros set to 0 these two coordinates, the y and the x coordinate. So what I'm going to find is exactly this corner. Why I didn't use this macro to find this corner? Because the object is inside this area, so this corner it's on the air. And the other coordinate I'm going to find is this, the most upper area on my object. So that's where I'm going to start probing from this top to the bottom of my object and on these two corners. So I'm going to use first the M903 macro, then I'm going to use the M902. Well, after I use this one, I have to move it to this corner. Let's try this one first. M903. So what I'm going to do to use it is only write M903, and it's going to tell me that the probe will move from the front where it is to the back of the machine and going to find the side. So I press OK, and it automatically moves. And when it touches that point, it gives you the machine coordinate of that point if you need it, and also set to 0 the y-axis and retract this this amount. So now I'm going to need to move to the other side, and I'm going to use this macro to find this edge on my skull. So I'm going to write here M902, and it gives me the message that the probe will move to the left of the machine, because now I am on the right, so it's going to move to the left. I press OK. It touches, and I give the value and set to 0. Now the only thing I need is the height. So I'm going to move the probe on top of the skull, and I'm going to try to put it exactly where I see is the more toppest area on my object. And I'm going to get the probe close to the object, and I'm going to run the M900 to find the height of the z-axis. Okay, it's going to move down the probe. There it is. Now I have this point, but on the space, because my object is here, and that's where I'm going to start to load the toolpath to scan all this area, because my object is inside that area. So the other thing I need, first I'm going to go to 0, and I have the coordinate on the space for my object. But as I told you before, I need to move my coordinates on y 1 millimeter to the bottom, so the skull gets inside the boundary box. So I'm going to allow down this. I'm going to move my y, sorry, 1 millimeter there. With that, I can ensure that my probe is going to be inside my problematic area that I have when I'm going to scan this. So I set to 0 here, and now I told you that the plugin is going to make a file. The problem right now with the macros is that the UCCNC doesn't allow to ask you questions. For example, asks you where you want to put the file or what's the name of the file you want to use it. So what I did is to put it inside the UCCNC folder, and so the file name is going to be here on the macro, and you can see that it's going to be saved on the UCCNC, and the file name is objectprobe.txt. That's the name of the coordinates, the point cloud we're going to obtain in this folder, the UCCN folder. Now the coordinates, or the file you're going to have is something like this, object probe. If you open this, you're going to see a lot of coordinates, and that's what you get. You can open this on Meshlab, and you're going to import to make the object again. Okay, because of the limitations that I told you before, if you want to make several scans or a new scan, every time you need to start again with the scanning process, because of this, it's going to save the object in the same file. You need to delete this file every time you're going to have a new scan. If you delete this, the next time you start probing, it's going to make a new one. So after you finish, you can copy this file to anywhere you want, or rename it, or anything you want to do with the file. But every time you start probing again, you need to delete this file, the object probe. Okay, so after we have the 0 for the scan, we're going to load the toolpath that we create, the square toolpath, so we can do the scan process. Okay, we'll load the file, and it's object, and you can see the simple toolpath that is square, that our school is going to be inside here. Now if we open the plugin, if you remember, you have to load the toolpath on the UCCNC, and the plugin is going to show you this screen. Now we're going to need a very good mesh to make a good scan for the school. If you remember, the size, it's going to be 7 by 10. If we put 7 and 10 points here, the probe spacing, we're going to have 1 point each centimeter here. If we double this, 14 and 20, we're going to have each half 5 millimeters here, and the points is going to be more and more on the quantity. So each time I double this, it's going to be the half of the size. If you want to make exact number of points, or a difference of the points in the area, you're going to need a little calculation here. For example, we have 7 centimeters here. So what we need to do, if we need 1 point each, 1.5 millimeter, what we need to do is 70, we have to divide it by 1.5, and we need 46 points to achieve that. So I'm going to put 46 points, and on the other coordinate it's 100 divided by 1.5. I'm going to need 66 points. So we put 66 points, and we're going to have a mesh that is made of points with a distance of 1.5 millimeters each. Now the clearance of the probe, the more you put here is the more height the probe gonna get after the 0, and the depth, it's gonna be the depth from the 0 to the lower part of your object. What I need is not too much clearance because I don't want to take too much time to scan each point, and the depth is going to be 25 millimeters lower from the zero, so I can achieve a good scan of the skull and the A holes. And also I'm gonna improve the feed to 500, so it's not gonna take too long to scan it. I put 500 here. I tested before, and you can go lower for harder materials, but because I know the probe is not gonna get damaged with the styrofoam, that's why I put 500. And it's because also this is gonna take a while to scan. And of course the manual zero is very important because we actually know what the zero is for the probe. We don't need the auto zero for this. And we are ready. We're ready to make the scan of this surface, and after we scan this, we're gonna get the point cloud. So I send the code back to the UCCNC, and we're gonna have this. This it's the Toolpath that's gonna scan all the surface. It's gonna start. Well, we are here on the zero, but it's gonna start in this corner, and it's gonna be point by point and scan everything here. It's gonna take a while. So after everything is ready, we put this to zero. The boundary is 1 millimeter on the y-axis, so my skull is inside. We make the toolpath. We check this, how many points we need. Everything is set, and I can start the cycle. And this is going to start probing all the way. So let's press start, and let's watch. Now that we have finished the scan process, we need to move the file. We have to stop this, and we need to move the file that we get here. Well, the next step here is going to mill the toolpath. We are not going to do that. We need to save the file that we have here of the 3D probe. I'm going to move it to the other side here. That's where I'm going to save my object. This file is a text file that have all the data there. And what I'm going to do is open this file on the Meshlab. So I open Meshlab, and here I'm gonna open the file that I saved. Import mesh, and it's gonna be here, works 3D probe, object probe. And these options I'm gonna let it right there because I modified the way that the data is saved so it match this format. So we say okay, and this is what we get. This is the point cloud of the scan. Now, what we need to do to make this as an object? Well, first, for those who doesn't have any knowledge on objects, a 3D object is made of points, and these points, what they do, it make polygons. These polygons can be made of 4 points, like a little square, or it can made three side polygons, that it's triangles. So what we need to do is set up the point normals. The point normals, each side of a polygon have a face that points. For example, let's say let me show you a picture of this so you can see what I mean. Okay, this is what I want to show you first. This is a polygon, 4-side polygon and 3-side polygon, and this is the normal of the polygon. This normal tells the polygon which side is facing, so you can see it. If the normal is in the opposite way, you cannot see anything. The polygons are not double-sided, it's single-sided, unless you tell the 3D programs to make it. But what we're gonna do is analyze these points and make the normals of these points facing upwards. So when we make the polygons for this mesh, it's gonna point out, to the front. This is another example of the normals. So you can see the faces that are pointing outside the object, so you can see the object. So the first thing we need to do is calculate the normals for this. If you see here, you can render the normals of this is a very complex program, by the way. So it have a lot of options, a lot of things for working with meshes. I'm not an expert on this, but I know enough to show you how to do this. First, if you render the normals of the object, you're gonna see that the axes are all crazy, are all around, and this is not good. We need to calculate this so the software knows those faces are outside. Luckily for us, the software do this automatically with a special plugin. So we're gonna go here on filters, go to the normals, and there is compute normals for point sets. We select this, and with these settings by default, we're gonna have a very good result. So the normals are gonna be much better. Actually, it's gonna be perfect. Apply the settings, and you can see automatically that the normals are pointing outside now. Each point has its own axis pointing outside. So now we can make the mesh right now, and we can make the polygons. These options here are for seeing the object as polygon, light, or anything else. Right now we don't have any polygons, we only have the points. There are several methods to to work with the polygons, but what I found best for this to have a nice result is this one. We're going to remeshing, simplification and reconstruction option, and all the way here there are 3 options. I don't know if you can see it. Let me lower the I'm gonna move the program so you can see the option. Okay, this is the option, val pivoting. This is the best option I found to make the polygons for the scan. When we select this, we're gonna have these options here. It's a special algorithm that simulates a little ball on the surface, so you're gonna see the result. If we play here apply, we don't see any results on the polygons, just more normals. But what we do have now, it's the polygons, so we need this to see them. If we put it here, now you can see much better. If we turn off the normals, you can see now the object that have. We turn on the light and you can see now the object. We can see these little 2 holes here, one here and one here. We can close those holes with an option. And to fix those little holes, we go to the filters, remeshing and simplification, and there is this option, close holes. We select this, we let this by default, apply, close, and we close these holes that we have here and here. It doesn't matter if we have this big hole here because it's not scanned, and also the toolpath that we're going to make, it doesn't need those. So right now we have the object, very nice, and we're going to save it. So we export the mesh as, and we are going to save it STL. So school STL, save. We left this here, and that's it. We have an STL object, and we're going to load it now on the Vectric software so we can make a toolpath. Okay, we're here on the Aspire. You can do it with the 3 carve. We create a new file. We're going to use the same settings because it's the same measure, and the thickness. Now let's say we have 30 millimeters thickness of our material, and let's press OK, and we have our material here. Now we go to modeling, and we go to import the component on 3D model. Now we have the STL that we made. It's the object from school. We open this file, and we have the mesh. Very good. Now we need to import it into an object. So I'm not going to modify anything, just center the model. That's it. And I'm going to tell the object that load a little more here. So I need more school right there. So I press OK, and we have our model. Oh, I missed a little bit here. But it's just a test. Let's do it again. Load the object. Let's center the model, and Let's move this there. Okay, we press OK, and we have this. Now we can make the toolpath right now. If we go to here on toolpaths, I can set first the rogue toolpath, press OK, the material setup, and then I'm going to select this end mill 3.1. Let's make this 4 millimeters because I'm going to make this on foam. Let's edit better so it doesn't alter my original end mill. Calculate. Oh, 20% of the tool diameter, doesn't matter. And that's a rough toolpath, so we can preview the toolpath. So you can see it's not too difficult to make and scan and reproduce it here once you have the point clouds. Meshlab, it's kind of complicated software if you don't know anything about 3D. So if you don't want to mess up with the software, with the options I showed you, it's more than enough. Now we need to make the final pass, that it's this one. I'm gonna make it with the ball nose, exactly the same diameter, and let me put this to 30. Okay, calculate, and let's preview the toolpath. And now we're gonna see the finish of this. Also, if you see, you can see the polygons on the object. That's because I didn't smooth anything, so you can see the rough polygons. Here you have a setting so you can smooth a little bit those polygons, so you can see those triangles on your object. Okay, now you can see how it's going to be milled or object. Of course, I'm using a big finish end mill. If you use a small one, you can get better results. Also, here on the smooth of the object, you can have, for example, the smooth. You can smooth the object. This is not smooth, and you can have more smooth, so you can have a better object, and without those polygons you can have much better results. Okay, this is just an example, and this is how you can achieve the scan results. Of course, this is a complex object. I want to do it with this kind of object, so you can see that complex surfaces can achieve this kind of results. Other kind of scans can be done, and well, if you make anything with this, it's going to be nice to see it on the Facebook page. Well, I'm not going to show you the milling of this, maybe later on with a picture, because I don't have too much time to make it right now. But I'm gonna mill it with another end mill here, so I have better results. And after that, I'm going to show you the original and the scanned milling copy, so you can see how accurate this came from the 3D probe. Okay, this is the end of the video. Take care. If you have any questions, please let me know on the Facebook page. Well, take care, everyone. I hope you find this useful, and ciao ciao.